The pH scale for acidity is defined by pH equals negative log base 10 of H positive, where H positive is the concentration of hydrogen ions measured in moles per liter. Now here we have a solution with a pH of 4.15. And what we're being asked to do here is to calculate the concentration of hydrogen ions in moles per liter. It says here to write our answer as a decimal in scientific notation using at least three non-zero significant figures. All right, so we have our formula in order to change between these two values. So we have pH equals negative common log of H positive. And I'm going to go ahead and just switch to regular parentheses instead of brackets. All right, now we have the pH level. That is given as 4.15 in the problem. So that's equal to the negative common log of this value, H positive, that we want. So to continue solving then, what we would need to do is get the logarithm by itself and then change into exponential form. And the reason we would do that is because the variable is in the argument of the logarithm. So we're not going to have any luck trying to solve this using logarithms. We need to switch over to exponentials. But before we can do that, we need to get rid of this negative, and that's easy enough just to divide both sides by negative 1. So now I have negative 4.15 equals the logarithm of this unknown value that we want. Okay, so this is in log form. We need to change it to exponential form. And notice that there's no base written in the logarithm, so it's understood to be 10. So it's a common logarithm which is always base 10. So we take the base 10, raise it to this exponent, negative 4.15, because the result of a logarithm is an exponent. And then that's equal to the argument of the logarithm, which is the value that we're looking for. So essentially, what I need to do is take the calculator and see what 10 to the negative 4.15 power is. So let's open up the calculator and see what we get. So I can say take 10, raise that to the negative 4.15 power, and I get a value 7.079. Then I have this e minus 5. So that's the way the calculator represents scientific notation. And it said it was fine to use scientific notation, but we'd want to write it like this. We don't want to use the e, that is. We want to write it 7.079 times 10 to the negative fifth power. And it did say to use at least three non-zero significant figures. I've actually got four significant figures, so it would have accepted 7.08 times 10 to the negative fifth, but because it was at least three significant figures, then we're fine. Any more than that is okay.